Have you ever wondered what happens to your data when it travels across the network? It's encapsulated in multiple headers, but most of them are consistent from source to destination. The ones that are changing are IP and MAC addresses. So in this video, we will do a packet walk focusing on these parameters. By the end of this video, you will be able to understand what happens to source and destination IP addresses as it passes through the network, what happens to source and destination MAC addresses as it passes through the network. But that's not all. We'll do this for private and public network scenarios, so stay tuned till the end of this video. Let's start with the private network with two sites. The source of the data is this computer with IP address 192.168.10.10. And the destination is a server with IP address 10.10.10.50. Each interface has their own MAC address. To start every packet walk, we need to identify four parameters: source IP address, destination IP address, source MAC address, and destination MAC address. Source IP would be the computer's IP address, and the destination is the server's IP address. For source MAC, it would be the computer's MAC address as well, but the destination MAC would be the default gateway's MAC address, since the destination IP is not in the same subnet. This MAC address is discovered through ARP. Once we have this info, we can take a look at what happens under the hood. First, the packet goes to the default gateway's interface in the local area network. Then router A routes the packet upstream to its wide area network interface. Same source and destination IP, but since the layer 2 segment changed, source and destination MAC address would change to the following. Source MAC would be the MAC address of router A's WAN interface, and destination MAC would be the MAC address of router B's WAN interface. After that, packet arrives in the next site in router B's WAN interface. Router B routes it to its LAN interface, changing the source and destination MAC address since it's another layer 2 segment. Source MAC address would be from router B's LAN interface, and destination MAC address would be the server's MAC address. Source and destination IPs would remain the same. Then traffic arrives at the destination. The reply from the destination will have the same flow. You just need to interchange the source and destination. Now let's look at it in a network with the internet. For example, a computer in your home network connecting to packetbrew.com with IP address 37.98.151.191. The network would have a NAT translating private IP to public IP. First, we start by identifying the source and destination IPs and MAC addresses. Source IP would be the computer's IP address 172.16.10.10. Destination IP would be the website's public IP address 37.98.151.191. Source MAC would be the MAC address of the computer, and destination MAC would be the default gateway's MAC address. Then, packet will arrive at the default gateway. The router will route it upstream to the internet. Since there is source NAT configured, the source IP would change, making the parameters source IP address 11.22.33.44. Destination IP would still be the website's public IP address 37.98.151.191. Source MAC would be the router's WAN interface MAC address, and destination MAC would be the next hop router's MAC address. Source and destination IPs remain the same as it travels across the provider's network, but source and destination MAC address would change as it travels to different layer 2 segments. Once it arrives at the website's network, another device would apply destination NAT to the public IP of the destination, changing the destination IP to the private IP equivalent. In this network, data would arrive at the destination. The return traffic will have the same flow. IPs and MAC addresses just need to be interchanged. That's it for this packet walk video. Like and subscribe for more networking videos. See you next time.